Okay, we're going to do 7, 8, which is inverse functions and relations. Okay, so 7, 8, inverse functions and relations. It says we've used the word inverse several times in Algebra 2. You guys can see this on your paper. The additive inverse of 3, do you guys remember that? -3, right? And the multiplicative inverse of 4 is 1/4, right? So additive inverse is what you add to get 0. Multiplicative inverse is what you multiply to get 1. All right, we've also talked about the inverse of a matrix. Now we're going to talk about the inverse of a function. So it says inverse relation. The inverse of the relation consisting of all ordered pairs x, y is a set of all ordered pairs y, comma, x. So you just switch them around. So it says the graph of an inverse relation is the reflection of the graph across the line y equals x. Okay, so if I have 0, 2, 1, 5, 5, 6, and 8, 9 for my normal function, that's f of x, or my normal relation, f inverse of x is going to be just switching all of those values. So I'm going to have, let me write the t-table for it. Yeah, so I'm going to get 2, 0, 5, 1, 6, 5, 9, 8. So I'm going to get those points. So I have 2, 0, 5, 1, 6, 5, 9, 8. Okay. Let's look and see what the original one was. So 0, 2, 1, 5, 5, 6. What, yeah, do you have a question? You got it? Okay. 8, 9. Okay. So you have those points. Okay, here's what the line y equals x looks like. So do you see if you fold across that line y equals x, all the points match up? Okay, that means that they're inverses of each other. So when that happens, it's an inverse relation. If you need to draw in some straight lines to help you see it, sometimes that helps people see it, like connecting the dots. But we don't necessarily have those lines there. Okay, so an inverse function is just going to be the function that undoes the other function. So it says if we put 3 into f of x equals x plus 6, we get 9. What's the function that if we put 9 into it, we get 3? So what's a function where if I put 9 in, I get 3? Okay. So it says if I have 3 as an x value and I plug it into f of x equals x plus 6, you get 9 out, right? 3 plus 6 is 9. So if I plug 9 in, what's a function where I get 3 out? So x minus 6, right? See how that works? So if you put 9 in, you get 3 out. That's called the inverse function. And you can check some other points. If you put 4 in your original, you get 10 out. So putting 10 in the new one, you get 4 out. So they're opposite each other. All right, they're not always that easy. That's not always where you just switch the sign. So we talk about how to find the inverse. So I always do 4 steps. First, I put in a y for your f of x, because that's what f of x is. It's the y value. Then since I switch points, you know, x comma y becomes y comma x, I switch my x and y values. I solve for my new y, and then I make that f inverse. Okay, so here we go. So it says find the inverse of each function. So first I'm going to write, so here's first step. I'll write my numbers for you. So I get y equals x plus 5 over 2. So that was my first step. My second step, I switch my x and my y value. So all the y's become x's, all the x's become y's. Okay, now I need to solve for the y value. So I'm going to have to multiply by 2 first, and then I'm going to subtract the 5 over. So I'm going to have 2x, so let me write step 3. So I have 2x equals y plus 5. So 2x minus 5 equals y.
That's step 4.
Nope, and then step 4 is once you solve for y, so we have y equals we replace it with f inverse of x. So it looks like f to the negative 1. That's read f inverse of x. So it's equal to 2x minus 5. That's your inverse function. So let's try this one. So I'm not going to write 1, 2, 3, 4. Step 1, you replace f of x with y. Step 2, you replace your x and y's. So it becomes x equals 2 plus 5y under a square root. Okay, I need to solve for that y value. So think about all the things you need to do to get y by itself. You're going to get rid of your square root, so square both sides. I'm going to subtract the 2 over. Okay, and then the last step to get y by itself is I divide by 5. Okay, once y is by itself, that's going to be your f inverse. So it's f inverse of x equals x squared minus 2 all over 5. Okay. And you can write it like that, or some people like to write 1/5 x squared or x squared over 5 minus 2/5. It doesn't matter. Like, see how they bring the 5 into both pieces. So either way you want to write it.
This semester's final, is that cumulative or is it just?
Cumulative for this semester, not for last semester. All right, number 3. So you guys want to try this one? So go ahead and try number 3. I'll pause it. Okay. Oops. Put it down here. So I have f of x equals negative 1/3 x plus 4. So I'm going to replace my f of x with y. Okay, switch my x's and y's. Oops, line. Okay, solve for the new y value. So I'm going to subtract the 4 over. Okay, and this is the part where most people get confused. They don't know how to get rid of the negative 1/3. So if you're going to get rid of a negative 1/3, just multiply both sides by negative 3, so by the reciprocal. So when you do that, you get negative 3x plus 12 equals y. So that means f inverse of x equals negative 3x plus 12. Or you could say 12 minus 3x as well. Okay, so that's, I think most of you guys got it. All right, the next one, so replace f of x with y. Switch your x and y. So get x equals 5 times y minus 2. Solve for the new y value. So you can do this a couple different ways. You can distribute the 5 first and then solve for y. Or you can just divide by 5 right now. That's the way I like to do it. I like to just divide that 5 over. And then I add my 2 to both sides. So I get y equals x over 5 plus 2. So that means f inverse of x is x over 5 plus 2. But you could see this written in another way. So if you had distributed the 5, you might have it written as f inverse of x equals x plus 10 over 5, which is fine. So either way, it's the same thing. All right, it says note, you can also find the inverse of a function f of x by graphing it. So by graphing and reflecting it across the line y equals x. Okay. Okay, so example 1, it says the theater sells tickets for $22. If you buy online, the theater adds a service charge of $3.50 to the entire order. Write a function that gives the amount billed as a function of the number of tickets purchased. So whenever you hear as a function of something, that's your x value. So like function of x, f of x. So x is your tickets, and y is going to be the amount billed. Okay, so let's think about it. it's $22 per ticket. So that means depending on how many tickets I buy, it's $22 for each one. So it's going to be 22x. So I'm definitely paying that much. But then they just tack on a $3.50, not per ticket, but just a $3.50 at the end of the order. Okay, so you get y equals 22x plus 350. Okay, let's find the inverse function. So if I find the inverse function, we're going to switch our x and our y. Solve for the new y. So I have x minus 350 equals 22y. So x minus 350 divided by 22. That equals y. Okay, this is where it gets confusing in these story problems because we've switched the meaning of our x and y for the inverse function. So for the inverse, x is now your number of tickets. Oh, sorry. X is now the amount billed. Thank you. And y is your number of tickets. So you can kind of avoid that if you wanted to do these story problems by not switching the x and y. Like you could just solve for the x variable. Does that make sense? So I think I might have one on your homework where it's like Celsius and Fahrenheit. Just leave them as C and F, just solve for the other variable. All right, so so when we find this, we're finding it the number of tickets purchased when the bill was $157.50. So I'm going to plug in $157.50 for x. Did anybody do that? What's it equal? 7 tickets. So 7 tickets. Okay, makes sense? Any questions?